Hi guys, in this video we are going to learn another interesting question from kinematics of particle. When we are telling about the kinematics of a particle, we need to consider the velocity as well as the acceleration. The main parts are these. So if you are new to this channel, don't forget to subscribe it. We have already done many questions regarding mechanical and electrical. If you like to watch this, I have given the link in the description below, so you can always watch that. Before going to the video, I'm going to jot down some points over here. In this question, we are going to mainly focus in the radial direction acceleration as well as transverse direction acceleration. When considering the velocities, we are going to consider these both, which means the transverse direction velocity as well as the radial direction velocity. So if you don't know the equation, it's not a problem all. However, I'm going to show what the equation is. But if you don't have any idea what's that, if you don't have any idea, just search in YouTube or for any theory videos. After that only, just go through this. So I hope most of you have already know the equation, but for reminding that, I'm going to tell the equations first. So when we are considering the point O, if there is a rod like this and with the length R, let's say it's going to rotate from this point from O in the theta, from the theta dot velocity, theta dot angular velocity, and the rod is going to increase its length by from time to time. So I have marked that. So it's going to rotate as well as it's going to increase its length. So when we are considering this, we need, as we all know, that there are two velocities. In the right direction, in the horizontal direction or in the radial direction, there will be a velocity as r dot. So let's mark it as VR. In the radial direction, velocity would be r dot. So most of you know this already. If you don't know, please watch any theory videos before watching this video. So I'm not mentioning all the stuffs how to prove this also. So it won't be useful for you also. So if you need, just go through it in the YouTube video. So in the radial direction, the velocity would be r dot. So it's not a big matter. If we are having in the time delta t, if there is an increase of delta r, it would be r dot. In the transverse direction, when I mark the theta dot as anti-clockwise, we already know the velocity would be in this direction. Let's say this is transverse, so I'm going to put as vt. Transverse velocity would be r into theta dot. So I have marked both. So these equations are enough. But when we are considering the acceleration, we need to know both transverse as well as radial. So when we are considering the radial acceleration, there are only two main components in the radial direction. This would be, so I am marking as acceleration of radial direction, would be r double dot minus r theta dot squared. So this is an equation, so it's enough to remember this one. And when we are considering the transverse direction, AT, this would be equals to r into theta double dot, second derivative of theta, plus 2r dot theta dot. So you need to remember this equation, otherwise you can't do this question. So these are the main important things I have jotted down for you. If you don't know this equation, please stop the video and write this. After that only continue this video. So also I have given some data over here. Just I'm going to read the question now. So please listen and understand the question. After that, try it in your own. At the end, just go through the answers. I have given the answers in the rest of the video, so you can also check with yours. So here the question is, the searchlight shown in this figure. So this is the searchlight. So the searchlight shown in this figure casts a spot of light. This is the spot of that light. spot of light along the face of a wall. So here I have mentioned the wall. This is the wall and the searchlight, and there's a spot. Also, they have already mentioned it's below 100 meter from the searchlight. So the searchlight is located below 100 meter from the wall. So determine the magnitude of the velocity and acceleration at which the spot appears to travel across. So they are asking about the acceleration and velocity of this spot, not asking about this anything, they are asking about this spot. Also, they have mentioned at which the spot appears to travel across the wall at the instant theta 45 degree. So they have also given that we need to find the velocity and the acceleration of the spot at theta is equal to 45 degree. The searchlight is rotating at a constant rate of 4 radian per second. So they have given it's a constant angular velocity, it's having a constant angular velocity, it's a main point. So when you see anything constant or uniform, just mark as constant, because when, as we all know, when there's a theta dot is a constant, we can directly tell that theta double dot would be 0. So when you are having something similar to constant or uniform, just mark and try to use that data in your question. So these are the main things they have given. So I hope you have already understand the question. Just pause the video and try to do it in your own. Okay, let's do the question. So when we are considering, we need to know what's happening in this image. So when the spotlight is going rotating in the anti-clockwise direction, the spot is going to move along the wall, which means the velocity and the acceleration of that spot will be in the horizontal direction. That's the main point you need to take before doing this. So that's the key point, which means the spot is going to move along the wall. In the other terms, we can tell the acceleration and the velocity would be in this direction only. Whether it can be in this direction, which means the left direction or right direction, but we don't know at that time. However, we can tell the acceleration and velocity components will be in the horizontal direction. So that's the main point you need to take before doing the sum. So when you have a problem, you need to find what's happening over there. So we have found that. So the next step, we already know when there is a point O, I'm recalling the theory, when there's a point O with a radial of r, when it's moving, rotating in the theta, as well as when the radius is increasing, we don't know at what speed it's going to increase, but when it moves like this, it's going to increase. So when the radius is increasing, we can use 4 main equation. We have already learned that in the start of the video. So I'm going to use that. However, how to use that 4 equation to find this V and A? We are going to find the velocity and acceleration at this point when it's moving like this. So the main thing is the component of that the 4 equation, which means the radial direction acceleration as well as transverse direction acceleration, as well as both velocities, the components of those which lies on the horizontal direction will be used by this spot. So that's the main idea. I'm going to repeat it again. We already know when there is a beam, it's rotating from a center O with the theta dot and the theta angle over there. So, and also the radius direction, so the radius is also increasing. We don't know what's the speed, what's the increasing speed, increasing rate. However, we can tell what's the acceleration as well as velocity in that point. But here we are going to take along the horizontal direction. We are going to take only the spot, not this light. So when we are considering this spot, it's going to be in the horizontal direction. So we need to find those things values, and we need to find the horizontal value. It would be equal to this. So that's the idea. So after that it would be very simple. So I have got the main idea. So I'm going to try this question. So there are many ways to handle this. However, this idea is the same, but there are many ways over here. So in the first direction, I'm going to jot down 4 equation. If I am considering the VR, radial direction velocity, I already know it would be r dot. And if I consider the VT, transverse direction, it would be r theta dot. And the radial direction acceleration would be, I don't know what the values are, but I'm going to write all these 4 equations, so it might be helpful for me. So r dot minus r theta dot squared a transverse would be r theta double dot plus 2r dot theta dot. So these are the equations. So let's substitute the values. Before that, we need to find what's the value of this r. So it's not a big deal, because we know that the length of this side would be 100 meter, and this is the angle of theta. We can directly tell r is equals to 100 over cos theta. This side r is equals to 100 over cos theta. We can directly tell that r is equals to 100 sec theta. The main thing is, don't substitute this 45, because when we are considering this r value, we need to substitute that, but we need to find the r dot from this. When we are differentiating this equation, we will get the r dot. So the main thing is, don't substitute at this instant, but when we are we derived the whole equation in terms of theta and theta dot, after that we can directly substitute. So first I have taken that r is equals to 100 sec theta. So I'm going to differentiate, because I need the value of r dot. So if I differentiate, so I'm going to get r dot is equals to 100 sec theta. If I differentiate the sec theta, it would be sec theta into tan theta, and I'm going to put that theta dot over here. So this is a basic differentiation. So we have found the value of r dot. So we can directly substitute the theta by 45 and got the value of r dot. As well as we need to find for r into theta dot. However, it's not big a deal, because we know the value of r at theta 45, and theta dot we have already know that 4 radian per second. So we have found this VT also. So from that we can directly find what's the velocity in the radial direction, which means in this direction, as well as transverse direction, this direction. But here, as I already mentioned, we need to find in this horizontal direction. How to find in this horizontal direction, which caused by these 2 velocities? We knew this angle here is, if it's theta, it's going to be 90 minus theta over here. If we are considering that, it would be 90 minus theta. In this case, it's not a big deal, because this is also theta 45. So this angle would be 45, this angle also would be 45. So we have already found that. So the next thing is, when we are considering, once you need to find these values and you need to substitute and get the answers. So for the next question, we need to find the acceleration. Before that, we need to find both the acceleration in the radial direction as well as in the transverse direction. However, when we are considering the radial direction, we need to find the value of r double dot. How to find that? Most probably you will guess it. We need to differentiate again. However, it's not a simple thing. You need to use the differentiation methods and just differentiate this. From that, you can directly put r double dot minus r, we know the value, as well as theta dot, we knew the value, 4 radian per second. So once you substitute, you will get the answer. So before that, you need to differentiate this one and find the value of r double dot. Likewise, you need to for finding the value of A transverse, you need to find theta double dot. However, the main thing I have already told in this video in the beginning part, as theta dot is constant, if we differentiate the theta double dot, it would be 0. So point over here. So when we are differentiating any constant value, it would be give the results of 0. So it would be very easy for us. So this part would be 0, and when we are considering this 2 r dot theta dot, by substituting the values we can get the value of r dot, and after that we can use the 4 radial per second. After that we can directly find what's the acceleration in the radial direction as well as in the transverse direction, and from that we can find what's the acceleration in the horizontal direction. So I think you will get this clear method. However, it's not an easy method and it's not a single method. There are many methods. The idea is the same. However, the idea is the same. You have many methods to solve this problem. So this is an interesting method. However, when this r double dot, it would be a little bit difficult. Why is that? When we are finding the r double dot, you need so this is not a big deal for any mathematics students. However, comparing to this method, there is another easy method. We are going to try in that method also. So let's take this. So the main point, the simple logic behind this would be, at this time we are talking about the horizontal direction, the horizontal direction acceleration as well as velocity. Then what would be the vertical direction acceleration or velocity? What you are thinking about that? Just pause the video and try. So most probably you will get that in that in the vertical direction, the acceleration as well as the velocity would be 0. So that's the main point we are going to use here. Why is that? As I already mentioned, the spotlight is going to move and not going to base. So we can directly tell the acceleration and velocity in this direction, velocity direction, would be 0. So two different equations from this. What are they? If we consider the VR and VT, as I have already marked here, it would be here in this direction VR, and we are going to find this at V45, and here 45 degree VT, transverse direction. So we at the first method we have only considered about the horizontal direction VT cos 45 and VR cos 45 in the horizontal direction. But when we are using this method, we can directly tell, if we consider the vertical along the vertical side, it would be VR cos 45 minus VT cos 45 minus VT cos 45 would be 0. Why is that? As I already mentioned, the vertical direction velocity and the acceleration would be 0 because it's not moving in the vertical direction. So from that we can directly tell VR is equals to VT. So how to find this VR or VT? We can directly use one equation. We can either use VR, which means the r dot, or we can use r theta dot. So this the value of this would be r theta dot. The value of VR would be r dot. From that we can directly tell, as we all know all the values for r and theta dot, I'm going to just substitute r theta dot. So from that we can find the VR and VT. From that we can find what's the value in horizontal direction if we know the VR and VT components. So I'm going to do the same method for acceleration too. As I have already mentioned, in the vertical direction, along the vertical direction, the acceleration would be 0. So when I'm considering this in this direction, it would be the same, AR is equals to AT. However, in the first method, the little bit difficult method, the step was the calculation of R double dot. So I'm going to ignore that step here because I have already get AR is equals to 80. So it's enough to find ATO on AR. As we all know, when we are considering the AR, we will need to find R double dot minus R theta dot squared. So I'm going to ignore this. So let's find AT. So in the transverse direction, we can directly tell it would be R theta double dot plus 2 R theta dot. So I have already mentioned that R theta dot is 0, so we can find this one. However, you need to find the R dot value here. However, it won't take much time as compared to method 1. So in this video, I have shown some interesting points. Oh yeah, there's a power cut, it's not a problem. The video is going to be end. So hope you like this video. If you have any doubts, just comment below. Thank you.